Welcome to Cookroid. Today we will be solving the valid parenthesis problem. In this problem, what we will do is we will be given an input string, and with this string we have to verify whether it is contains a valid parenthesis or not. So to take an example, let's just see. This has a same pair of opening and closing bracket, so that's why it's true. And this also has same pair, meaning first small bracket gets closed, then the array brackets, they get closed, square brackets, some people call it square brackets as well, and then the curly brackets open, curly brackets close. That's why it's true. And then in this case, small bracket gets open, but it never gets closed. That's why the output is false. Uh, so that's the basic concept of when we will say the string is a valid parenthesis or not, when the open brackets and closed brackets closed by the same type of bracket which they have already mentioned here. So small bracket close, curly bracket close, and square bracket close. So how we go with this approach? Let's just take a simple example of a little, let me just type it here. So let's say we have a bracket or a string which looks something like this, right? Now, in this, we will not know till what time to go inwards. We will not know when the closing brackets get started or not. So to use stacks come, a stack data structure comes handy when we need to deal with this kind of problem. So what we will do is when we will iterate through the string, and we will keep pushing on the opening brackets like these. And then as soon as we see a closing bracket, we will pop out. Now, when we say pop out, so this will be the term which will pop out. So we can compare if this and these two things basically they match up or not. And if they do, then we say it's a valid string, and if they don't, then we'll say it is not a valid string. You can also consider it as a way that it's a recursion call, because until and unless this part is valid, uh, this part is invalid, the whole string gets invalid. Then we will look at this part, and then we will look at this part. Let's dry run our code first. I'll delete this stuff for now. Uh, and let's just say we have an empty stack to begin with over here, right? So when we encounter this array, this character, the first element to push will be this thing, right? The next one will be this guy, and then third one will be this guy. Now we encounter an opening bracket, so we will pop this thing. So the when we say pop, the topmost elements get popped up, so the output will be this, and we'll compare if this character is corresponding to this character, then we'll just pop it out. So now our stack will be like this. We'll have two elements, and then we will pop this out. So our output will be this for the pop, and our character ch or whatever is this thing. So they correspond to each other. So that's the way we want to write our code. Let's see how this looks in the code format. So for this, first step we have to do is we have to take a stack of characters, right? And then we'll iterate over the string, which we can do it as character ch s dot to char array. This will help us iterate over every character of a string, and then we'll say if ch equal all the opening brackets, basically this, or oops, or ch equals this, or ch equals square bracket. Oops, square bracket. Then what do? Then we push to the stack for these three kind of things. We push. So we'll say stack dot push ch, right? And if it's not any of these, then it comes to the else part, and then we'll want to pop these items. So we'll say if ch equals this and stack dot peak. Now what does peak does? Peak tells you the last or the topmost element of the stack, but it only peeks through it. It doesn't pop it out. It only peaks and let us know that okay, the last element is this. So the corresponding element for this is this guy. So what should we do? We should stack dot pop. If it is correct, then we'll pop it out. So what we are doing over here, we are saying if the element is this, check the last element. So let's just say our stack was like this. So we will peek it. If the element is this, example, our condition will come when we light this. If it is a closing bracket like this, check what is the last opening bracket. Check what is the last opening bracket. And if it is same, if they correspond to each other, then do stack.pop. And similarly, I'll write all of my other conditions. Curly bracket, stack.pop. Oops, stack.pop. And I'll write my third condition, which should be for the square array. Stack.pop. Right, and else I'll just say return false. Right, and this comes the else part, and then we come out of the for loop, and out of the for loop, if we come, so what we will just return, we will say if the stack is empty, that means we have popped out all of our elements and none of the elements is existing there. So return true if it is empty, and false if it is not empty, meaning there are some elements which should be popped out but the stack is not empty. Now let's just run it once. Oops, should have added arrow here. Okay, it's like this. Okay, let's run it again. Okay, so this use case is specifically accepted, but there are some use cases when stack may not have anything in the else condition. So we should just write if stack dot is empty. If it is empty over here, there is just one element or something like that, we'll just say return false, because we are still iterating to the string, meaning our string is not completely parsed, but our stack is already empty. So why do we need to go even further? So with this, we'll just submit our code and see. So that runs fine. So that's the output. That's the solution for valid string parentheses. Okay, thank you everyone for joining in. Bye.